Hello, welcome to my tech farm. A few months ago I tested 3 different resins from the Sunlu, and looks like they like my testing methods because they sent me another one. Well, not directly to me because I still don't have a solution at home for the printing of the resin. So they sent the resin to the filastin company and they printed these test objects for me. And I got actually these test specimens from the filastin company. They are printed on Iligumar 3C printer, and I will use here the same test objects like from my previous video where I compared those 3 resins, so the results are comparable with each other. These are those test objects. I have this printed horizontally and vertically too. This one is for creep test. This is for the shrinking, but I can see quite big elephant foot, which I will remove. And this is the traveler. Look at these small details. And actually I have this test from the previous video. I throw them from 2.5 meters to the ceramic tiles and do it 3 times, and we will see which part will break or will it break at all. And now we start with this throwing test from 2.5 meters to the ceramic tiles 3 times. Not bad. From these 4 objects, 3 pieces are completely in one part, and only from this one the map broke down, but everything else is in place. The tensile pulling test with horizontally printed objects. And these holders are CNC machined by PCBWay. And now vertically printed objects. Visually the break is very similar in all 4 cases. Two-sided shell threads with the 5mm diameter object, and I'm curious if it will be shelled correctly in 3 pieces or it will just explode like many rigid resins I tested on this channel. Well, it was shelled correctly, slowly and continuously, like it would happen with the regular filaments. And this is 3-point bending test. Distance between supports is 50 millimeters. And I'm placing these loads one by one and follow the deformation after 1, 30 and 60 seconds. This is speed up time lapse. The deformation under 1.25 kg, 2.5 and under 5 kg it completely deforms. And after 30 minutes it almost gets back its original shape, very minimal permanent deformations. And now my regular creep test, where I am measuring the deformation distance between 2 reference surfaces under the constant load. And I have 3 experiments in progress. At least we have some comparison between them. So this one is the easy ABS, this is the PLA, this one is the annealed PLA, and this is some resin material. The load will be 1.25 kilograms as always. And I can see the resin will not survive even the first 10 minutes. What a moment. And what is interesting, the next day it got back its original shape. And now I will see, is it really high tough resin with this size of impact tester. High tough resin, 0 position. These are 2 edge positions of the hammer, and the edge difference in the height is 19 millimeters. It will be used in calculation for the breaking energy. The torque or twist test, I have this test object 6 mm in diameter, and this side goes into the torque meter and the other side goes into the vise. And I want to record the load at 90-degree angle and the maximum load. 0.7. 1, the peak. Interesting, sometimes the resin is very brittle material and I cannot even make the 90-degree angle, but here I made 1 full turn, or even more, and then it suddenly breaks. This is my temperature test in the oven, and I have several experiments in the progress. This is the PLA, annealed PLA, easy ABS and high tough resin also by Sunlu. And I'm recording the temperature of the first significant deformations. This is a time-lapse video speed up 25 times, and this object is our resin from this experiment. And I'm following this gap here because I want to record the temperature of the first deformation. And maybe it's happening now approximately at 105 degrees Celsius, but it is not so obvious. And here actually it stopped with deformations. I went up to 180 degrees Celsius. For the moment the light turned off, but no additional deformations on it. So the real big question is when it starts with the softening, so on which temperature can it be used? Well, because of the other materials in this test, I stopped the experiment on 180 degrees Celsius, but even on this temperature it was already very soft, so we cannot use it on this temperature. What is that temperature where we can use it? I'm not sure, I cannot figure out with this kind of testing, but definitely the temperature resistance is better than those regular filaments like ABS or similar. But even now, after 1 minute, it is completely hard with very minimal permanent deformation. Let's summarize the results in this Excel table, and I will include here the results from the previous video. These are 20-minute cured versions because I had there 2 and 20 minutes for the comparison. The creep test. Well, you saw the weight fall off after 10 minutes, so that is not included in this table. The tensile test and the layer adhesion test, well, you can be seen on this graph that the high tough resin was the weakest in this test, but interesting that it is equal, independent from the orientation of the printing. The shear stress, it was again weakest, but the difference is much smaller. The bending test, now this is the deformation after 30 seconds only under given load, but more useful is this table, well actually this graph. And here we can see that even on 2.5 kilograms, this is almost linear, so it didn't stop with creeping, with deformation, and on 5 kilograms it completely deforms. Until other series resin could survive even 10 kilograms. Of course, there was creeping, but they are holding the position. Torque or twist test, again it was the weakest in this test, but very interesting information that I could make more than one turn until it completely failed. And isod impact test, well, high tough resin, I was expecting here better result, but actually the rest of the resins, unfortunately I don't have that ABS 20 minutes cured version, but even the 2-minute version, I think it was stronger here. Now maybe not perfect temperature test for these materials, but I think I noticed a small deformation on 105 degrees Celsius. Now then it starts with the deformation and I went up to 180 degrees Celsius and no additional deformation on the test object. So a really weird question when it starts with the softening, so on which temperature can be used, maybe around 100 degrees Celsius, I'm not sure. And my figure dropping test, only one object has some broken element. Others will survive, but in this test, again, the ABS-like resin was the best. All 4 objects survived this test. I almost forgot here to include the shrinking test results. I measured them in all 3 directions, and the average is 99.6% in the X, Y, and Z direction. I don't think there is a need some conclusions, the results tells you anything. Maybe this material is something like semi-flex material or close to it, because even if I bend it with a bigger deformation, after some time it always gets back its original shape. But of course, depending on your application, I think the ABS-like resin is still my favorite, but if you have some additional experience, flow lines in the comment section. Thank you for watching and happy printing!